Hi guys, in this video we're going to be talking about polynomials in a geometric framework, which essentially addresses how to combine polynomials using different operations. So let's talk about a couple of basics. What an equation is a bunch of terms that equal something. So if this was an equation, we would have this equal to, let's say, 5 or something. This is not an equation, so it's not equal to anything. This is an expression. When we talk about polynomials, often we hear the words term. All a term is an element inside the expression or the equation. So this fella here and this fella, all of these are separate terms. So now what we want to learn to do is combine these polynomial expressions using different operations. The operations we're talking about is addition, subtraction, and in this case, multiplication. Dividing polynomials is a whole subject matter in itself, so we're not going to talk about that here. When we combine polynomials, the way we do that is we combine like terms. So the first thing we want to do is identify the like terms. What I did is I color-coded the like terms based on their exponent, or this little number here. And we could see here that the 5x squared, the little 2, is highlighted red, while the little 4 is highlighted blue. The little red numbers are like terms. That makes the 5x squared and the negative 8x squared like terms. The negative 3x to the fourth and the 5x to the fourth are also like terms. Now, if you notice, I did not use the terms subtraction. When we're combining like terms, we're really adding positives and negatives here. So I'm not looking at this in terms of 5x squared minus 8x minus 3x to the fourth. To make things confusing, some people will communicate this expression that way. It's often communicated that way. But when we're combining the terms, we look at this subtraction sign as a negative and not as an operation. So let's clarify that. I stacked my like terms based on color and in exponential order. So you will see that I have 3x to the fourth color-coded blue, and I put those two together. So I put the negative 3x to the fourth and the positive 5x to the fourth on top of each other. I then took the red 5x squared with the negative 8x squared and piled them up on top of each other, and then the negative 8x and the positive 8x I put last. I also put these in exponential order. So you'll see that the 3x to the fourth is first, the 5x squared, then the negative 8x. For the sake of this example, I did not put the plus signs. So we want to treat these like positive and negatives, and we're just adding them individually. When I do that, negative 3 plus 5 is 2. So this term will be 2x to the fourth. 5 plus negative 8 is negative 3. So this will be negative 3x squared. Negative 8 plus 8 is 0. So for this example, we combine the polynomial using addition, and this is my combined polynomial. If you're asking yourself, what is the point of this? My response is, it is just a skill set. We're not actually solving any problems here because there's no application. Let's take a look at the next example. In this example, we're going to see that we have a subtraction sign instead of an addition. The rules are essentially the same, but there is a minor step here that is very easy to forget, and we want to make sure that we remember to distribute this negative. I once again color-coded the like terms using similar numbers. But what I have to do here is I have to distribute this negative, and there's a reason for this. When we're subtracting polynomials, I am not subtracting this 5x from this 7x, 6x to the fourth plus 8x squared. I am subtracting this entire polynomial from this polynomial. So what does that mean? That means that because we have individual terms, we need to distribute this negative to those individual terms so that we can then combine the terms in the form of subtraction. It's a little bit abstract here, but let's bear with me and see if we can clarify this. What I want to do is I want to essentially distribute this negative. And what that looks like, it's like multiplying these by -1, or in simpler terms, changing the signs. So this positive 5x becomes a negative 5x. That positive x to the fourth became a negative x to the fourth. Now hopefully this is where things get a little bit clearer, because the negative 2x squared became a positive 2x squared. So let me just make this clear. The positive, when multiplied by -1, became a negative 5. The positive x to the fourth, when multiplied by -1, became a negative x to the fourth. And the negative 2x squared became a positive 2x squared. Hopefully that helps clarify. Often students say, well, you're just changing the signs. And that's absolutely the case. So now what I did is I brought down my terms on the left. I color-coded them for you so you could see the like terms a little bit clearer. This time, instead of stacking them like last time, what I'm going to do is I'm just going to combine my like terms in order. So first, I am going to combine my powers of 4. I'm doing that because it's the largest exponent, or the degree of the polynomial, and it's going to be the first term. So positive 6 plus -1, there's a secret -1 in front of that x, becomes 5x to the fourth. Then I'm going to combine my other terms. So I'm going down in order here. So my next exponent is the x squared. I'm going to combine those. And 8 plus 2 is 10. Then 7x plus -5x is 2x. So that's plus 2x. And that is my answer. That is the simplified form of this expression. All right. Now, here's the geometric framework of this unit. What we're going to do is we're going to have to find the area of this rectangle where the sides are in the forms of polynomials, or in this case, binomials. What we're going to have to do is apply the formula of a rectangle. In this case, the area of a rectangle is length times width. So what we want to do is multiply these two polynomials together. The way I'm going to do that is I'm going to rewrite the polynomials next to each other and place them in parentheses. This is the standard method, or the textbook method, of multiplying polynomials. There are a pile of other ways teachers will teach to do this. I am going to teach you the textbook method, and there's a very important reason for that. So what we're going to do is we're going to use the distributive property. That's the way you multiply something into something else that have multiple terms. So you'll see these arches a lot when people do this. I'm going to multiply x times x. X times x is x squared. Now I'm going to multiply x times 12. So that's plus or positive 12x. All I did was I took this x and I multiplied the x to the both of them. So in this example, I'm going to keep using different colors as I do this. Now I have to take this 7 and multiply that to these two terms. So I'm going to take this 7, and 7 times x is 7x. And 7 times 12 is 84. From here, I have to apply the rules I applied before. So I have to identify my like terms, which I only have 2 here, and I'm going to combine those. So, with that being said, this 7x is to the first power, and that 12x is to the first power, so those two combine. X squared has no friends here, and 84 has no friends, so they just come down. So I'm going to add these two together and get 19x. Then I'm going to bring down everything else. And that's the area of this square or rectangle. It's a little bit of an awkward problem, but the operation here of multiplying polynomials is very important. Okay, so I'm going to go through the next two examples a little bit quicker, but all they are is a combination of the first 3 examples. We're applying those same rules. So now I need to find the area of this triangle. Again, we're forcing polynomials into a geometric framework. This does actually happen in higher level math classes. So I'm going to use this form of the equation for the area of a triangle. Another way the area of a triangle is often written is like this. I find it tends to be easier to handle this way, but either way is fine. So what I'm going to do is I'm going to have to multiply these two expressions together, or these binomials, if you like. And I'm going to have to do that by distributing. I'm going to place the 1/2 or the 2 underneath this equation. For this example, I decided to just place the 1/2 there. It'll be easier to see how I'm distributing. I'm not going to go super crazy with my colors this time. So I'm going to distribute this 4x to the 7x, and that's going to give me 28x squared. Then I'm going to distribute this 4x to that -4, and that's going to give me -16x. Now I'm going to distribute the -2 to the 7x, and that's going to give me -14x. Then I'm going to distribute the -2 to the -4, and that's going to become +16. I was getting a little ahead of myself there. Now, just like last time, I have to combine like terms. So these two like terms here combine, and that's going to become -30x. Then I'm going to bring down my +16 and my 28x squared. Now here is where you have to be really careful, and you have to handle this your own way. That 1/2 needs to come down. I didn't bring it down to make the distribution a little bit clearer, but that 1/2 was here the whole time and is here now. Because we did not handle the 1/2, it has to keep coming. It can't just disappear. which is a very common mistake. From here, I'm going to just distribute my 1/2 into my individual terms. So 1/2 times 28 is 14x squared. The exponent doesn't get touched. The exponent is attached to the variable anyway. 1/2 times negative 30 is negative 15x. And then 1/2 to 16 is 8. And that is the area of a triangle. Again, I know this is awkward. It's a very important skill set for more advanced math courses. Let's do one last example. So the volume of a rectangular prism. All volume is the area of a 3D object. Now, what we have to do here is we have to multiply all 3 of these polynomials together. This could be very confusing, so you want to take this one pretty slowly. I'm going to multiply these 3 polynomials because the volume of a rectangular prism is length times width times height. Now, a couple things before we get started. For starters, it does not matter which order you write these polynomials in because you are multiplying. The only time this type of thing would matter is if you're dividing or subtracting, which we're not doing in these problems. Now, the other thing, you cannot multiply all 3 of these together at the same time. That is a general rule, even into very advanced maths. You always pick 2, multiply those together, then put the third one into the equation or expression as you need. I'm going to combine the x plus 6 and the x plus 9 first, so then it's visually easier to follow. So I'm going to multiply these 2 x's together, and that is x squared. Now I need to multiply this x times that 9, so that's plus 9x. Remember, distribution, so that means I am taking these terms and giving it to the other term. I'm going to multiply this 6x together. Sorry, got a little ahead of myself there. And then 6 times 9, multiplying together, get 54. This looks like a lot. Just be patient with it. I brought down the x plus 15 because we didn't touch it, just like in the previous example where I had to bring down the 1/2 because we didn't touch it. Keep in mind, these rules never change. So now I'm going to distribute all of this, and it's going to get pretty intimidating. Be patient with it. So x times x squared is x to the 3rd. X times 9x is 9x squared. X times 6x is 6x squared. And x times 54 is 54x. I'm now going to distribute the 15 to all these terms. So 15 times x squared is 15x squared. 15 times 9 is 135x. 15 times 6 is 90x. Then 15 times 54 is some absurd number, or 810. Now, if you think I'm some kind of genius, I promise you that's not the case. I am pausing the video to use my calculator to get these numbers. Now from here, again, just applying the same rules as before. So I'm going to look for like terms to combine. So let's see what we have here. I have a 9x squared. I have a 6x squared. They can go together. Then I have a 15x squared. They can go together. And I'm actually going to do that now to get them off my plate. A 9 plus 6 plus 15 is 30. So that's 30x squared. we can get rid of these to clarify this. I also brought that x to the third down. So let's see what else we got going on. Okay, now I have 5x, 54x. See how easy it is to make a mistake here. 135x and then 90x. So let's add those up together. And that is 279x. That is a crazy number. And that's often what happens with these. Now, the last thing I have is this 810, which has no friends, so I just bring that down. And that is the volume of this prism. These problems could be very frustrating, so you have to be very patient with them. But I promise you, if you can get this type of polynomial combining down, this type of math becomes very straightforward once you see the pattern. All right, guys. Sorry for the long video. I hope this video was helpful.